The next reaction I'm covering now is addition to a carbonyl group. So here's a carbonyl group, and the characteristic of reaction of carbonyl groups is addition. So various nucleophiles can add to the electrophilic carbon in a carbonyl group, and so a nucleophile is going to come and add like that. Now the thing is, there can be a few different nucleophiles, and I'm going to give you 3 different examples now. So here's the first example. I'll call it 3A. This is where the nucleophile is going to be an alcohol group. So there's our carbonyl group, and our nucleophile down here is an alcohol. So the alcohol is going to attack the delta plus carbon of the carbonyl group, and the carbon's already got 4 bonds, can't have more than 4, so we have to break a bond. So we're going to break the double bond there, move the electrons up onto the oxygen, and so that will give us a tetrahedral intermediate. So there's an O minus there now. That oxygen is now an O minus, and now this alcohol has become attached. And there's still a proton on there. So that's our initial tetrahedral product of the reaction. And then there's 2 boring acid-base processes occur. We have a boring deprotonation here and a boring protonation here. And you know how to do the curly arrows for those. In an exam situation, I'm not going to give you marks for that. I just expect you to write something like this, plus or minus H plus. Just give me a little message that you know what's going on. And then this will be the final neutral product of the reaction, a hemiacetal. And that's it. Okay, so that was the first example of adding something to a carbonyl group. The next example, example 3b, is where we're going to add same carbonyl group, but now we're going to add something different, which is a reducing agent, so sodium borohydride. So here's the borohydride. This is the important part of it. It's also got a sodium counterion, which is not so important. Okay, there's the borohydride. So the borohydride is the nucleophile, and the borohydride is kind of like a H minus source. So this hydrogen atom is going to depart along with these 2 bonding electrons, and that's going to be the nucleophile. So we can draw an arrow starting from here. So the H minus is going to attack here, and from there on it should look very familiar. So this was a trigonal carbon. It's now going to become a tetrahedral carbon, and the hydride has added onto here. And now finally there's a boring acid-base process, which I don't expect you to do the curly arrows for, even though you know, and that's going to give you this final product, which is, of course, an alcohol. So the overall process is we've reduced the carbonyl group into this alcohol. Okay, and our final example, 3C, of what we can add to a carbonyl group is an amine. So the amine is going to be our final nucleophile. So the nitrogen is the nucleophile in this case, the lone pair on the nitrogen. So it's going to attack our carbonyl group. I hope this looks very familiar. And that will give this tetrahedral intermediate. And you notice to get to there, I've kind of been a little bit lazy, and I've protonated on the oxygen and deprotonated on the nitrogen. So there's been 2 boring acid-base reactions that I was too lazy to draw in, but I expect you to know how to do those. But this will be okay for the exam situation. Okay, now remember that when you've added a amine to a carbonyl group, this is only the initial product. It goes a little bit further. So what happens next is we're going to lose water. There's an elimination process. So some random base is going to come along, and it's going to pull off this proton here, form a CN double bond, and kick this out. And so that will deliver you this as your final product. And it's got a carbon-nitrogen double bond. It's called an imine. So it looks like a complicated sequence of events, but actually it's very simple when you look at the overall pattern. You turn a C double bond O into a C double bond N, and that's it.